Bismillahirrahmanirrahim. Next subtopic of this chapter 2, which is the concentration of the solution. Before we discuss how to determine the concentration of the solution, we have to fully understand what is the solution is. Solution is actually the product when we have a solute that is dissolved completely in a solvent. Solute is the bahan larut in Malay language, and solvent is the pelarut. So we dissolve the solute, the bahan larut, into the solvent, the pelarut, and the product will be the homogeneous mixture, and this homogeneous mixture is what we call as a solute. So if we represent it in an equation, when we have a solute, we dissolve it in a solvent, then we will get a solution. It is represented in this figure, when we have a certain amount of the solute and then we add a solvent into it, and finally we will get a homogeneous mixture that we cannot differentiate where is the solvent and where is the solute, so that we call this as a solution form. When we talk about the solution, it is always expressed in terms of the concentration of the solution. It's either the solution is concentrate or the solution is a dilute one. There are several units of the concentration that we can use when we want to express the concentration of the solution. So some of them are molarity, mole fraction, percentage by mass, percentage by volume, and ppm. So I will discuss with you the first two units of the concentration, and another 4 will be your homework. Please search the method to calculate it in your textbook. So the first one is the molarity. It is defined as the number of mole of the solute per cubic decimeter or per liter of the solution. Mole of the solute over volume of the solution. It's either in a liter or the m cube. They are the same. We have to remember the conversion factor that 1 dm cube is equal to 1 liter. 1 dm cube is equal to 1000 cm cube. And we also know that 1 liter is equal to 1000 ml. So that 1 cm cube is actually equal to 1 ml. So the unit of the molarity will be mole per dm cube or mole per liter, or we also can write it as molar. Let's look at to the example. We have a solution of 1.71 sucrose that is dissolved in 500 ml of water. So when we got a question, firstly we have to identify what is the solute, what is the solvent, and what is the solution. So in this case, the solute is sucrose that is dissolved in H2O. Solute, solvent, and it will form sucrose aqueous. This is our solution. Our sucrose is 1.71 gram, and then the solvent is 500 ml, and it will form 500 ml of the sucrose solution. Actually, the solvent is not the same as the solution. As the solute plus solvent, then it will produce a solution. But normally we will assume that the volume of the solvent is the same as the volume of solution, unless the question stated the actual volume of that two are different. If there is no information on that, then we will assume that they are the same. So we know that when we want to calculate the molarity, we have to have a mole of the solute and also the volume of the solution in liter. So there is no information on the mole of the solute, means that the first step, by using the mass of the solute that we can calculate the number of mole of the solute. So mole of sucrose as the solute is equal to mass over molar mass of it. So the mass of the sucrose is 1.71 gram. Divide with the molar mass of the sucrose is 342.30 gram per mole. So gram cut with gram, we will get the number of mole of the sucrose is 5.0 exponent -3 mole. So from this number of mole, we can plug in the information here. 5.0 exponent -3 mole of the solute over the volume of the solution is 0.5 liter. Remember to convert the unit of the volume from mil to liter or from mil to dm cube. And then when we press the calculator, we will get the molarity of the sucrose solution is 0.01 molar. Please answer this question for exercise. Then we move to the molarity. Okay, so the molarity is defined as the number of mole of the solute. Okay, it is the same as the molarity. The number of mole of the solute that is dissolved in the solvent, okay, in kg unit. So if we want to calculate the molarity, we'll use this formula. Okay, mole of solute over mass of solvent must be in kg unit. Okay, this is what I said just now. Volume of the solution is not the same as the volume of solvent, as the mass of the solution is actually equal to the mass of the solute plus with the mass of the solvent. And the unit of the molarity will be mole per kg, or we can write it as molar or the small letter m. Example, calculate the molarity of sulfuric acid solution that contain 24.4 gram of sulfuric acid in 198 gram of water. Look at the information that we have. We have 24.4 gram of sulfuric acid, and we have to identify that this is the solute. Sulfuric acid is the solute, and 198 gram of water, this is mass of solvent, as the sulfuric acid is dissolved in water as a solvent to produce sulfuric acid aqueous. So molarity equation is mole of solute over mass of solvent in kg. Okay, we have the mass that is given 198. Okay, however, we don't have a mole of solute. Okay, so from the mass of the solute that is given, the first step is to calculate the number of mole of the sulfuric acid. So mole is equal to mass over molar mass. So the mass of the sulfuric acid is 24.4 gram, divide with its molar mass is 98.08 gram per mole. But press the calculator, we will get the number of mole is 0.25249 mole. Okay, and then we can plug in the value to the next equation, molarity. So mole is 0.249 mole over the mass of the solvent is 0.198 kg. So that we will get the molarity of this sulfuric acid is equal to 1.26 molar. Or we can use other unit, 1.26 mole per kg.